What if your AI model could detect exactly what you need in your unique environment? Generic Yolo models are great, but not tailored to your use case. In this video, learn how to fine-tune Yolo on your custom dataset for precision, focus, and real-world performance. By the end, you'll not only understand how to train Yolo, but how to make it work for you. Step 1. Creating a virtual environment. We start by creating a virtual environment using this command. Now, I'll activate the environment for our Yolo project. We can also check which module is currently available using pip list. As you can see, there is only the pip module available in our environment. Step 2. Downloading requirements. Now, installing the Ultralytics module. This will also install Dependencies module to train Yolo model. While it's installing, go to the official PyTorch website and find the Torch version suitable for your system. Copy the command from the website and paste it in the terminal once Ultralytics installation is complete. Now we can verify that all required modules have been installed using pip list. Now let's jump to step 3, labeling dataset. To train our Yolo model, we first need annotated data. We'll use the Labellerr annotation platform. Start by creating a new workspace. We will name our workspace as hand detection and click create domain. Our dataset type is image, so we choose image. And name our dataset hand. Give it a description and upload all your images. I'll be doing it quickly. We have also covered almost all of our features on our channel. Do check them out in case of any trouble. So yes, all the selected images are uploaded. Now clicking on Create Dataset to add images to our workspace. Create an object named Hand and choose bounding box as the annotation format. We name our project as Hand Detection and click Create Project. Let's start labeling. We should choose our object class, which is Hand here, and start drawing the bounding box on our image with precision. We will continue this process until all our images have been annotated. We'll click on the Submit button and annotate all the hands in our dataset. Step 4, customizing dataset to Yolo format. Now, after our dataset is annotated, we should divide the datasets into 3 folders, namely Train, Val, Test. These folders should be used in training, validating, and evaluating our model. Each of these should contain 2 subfolders, Images for image files, Labels for Yolo format annotation files. Now in data.yaml, specify the paths to train, val, and test images. Also define the number of classes and their names. This YAML file is necessary for our model training as it will provide the location to all the dataset on which the model should be trained. Our dataset is ready for fine-tuning. We can go to the next step. Step 5, training Yolo model. Yolo model training script is simple, but choosing well-configured parameters is important. Each training argument plays a crucial role, so choose wisely based on your system. Each argument has a purpose in model training. Like this will represent image size. Batch represents batch size, meaning the number of images taken at once by the model. Optimizer will add them. LO will be initial learning rate. Device represents which GPU to use. Name represents model name. Save will save our model when completed. Save period will save our model weights in a particular chosen interval. And the list goes on. Let's start the training script. You'll see Yolo initializing, and the model will begin training. I have chosen epochs equals 100. That obviously means the model will iterate through the training images 100 times. And training time depends on your GPU power. Wait till the model is getting fine-tuned to your dataset. Step 6, validating the model. Once training is complete, a new folder is created, from where you can copy its relative path and paste this into your val script. Here, the confidence argument plays an important role, as it signifies the model's confidence threshold for a prediction to be considered a detection. Here, It's set to 0.9, which means 90%. Run the script and wait. After a few minutes, a val folder will be created inside the runs directory. This folder contains metric graphs, validation image outputs, and predicted image results. You can roam this folder and see how your model performed on the val dataset images. Now validation process is completed, you can see all the metrics values as output. You can copy the result and paste it into another script for future evaluation. As we can see, our model trained well as its scores are great. Precision equals 0.999, recall equals 0.999, and other metrics are also great. We will further evaluate these results in a future video. Now we go to the confusion matrix of our model. As we can see, it shows great results. The confusion matrix is great for analyzing model performance, especially for models with different classes. You can use it to further study your model. Step 7. At last, use this command line to inference your fine-tuned model through Webcam. For more insights and a deeper understanding, check out our detailed blog on this topic. Link is provided in the description.